It's the Crab Nebula. It's the remnants of a supernova explosion. Lit. Discharging a certificate of honor, idiom, figure in a hurry to find a way out of a difficult situation. It's about 6,000 light-years from Earth. It's like a graveyard of celestial bodies. Countless billions of kilometers of dust and gas. It looks dead in here. But this may just be the calm after the storm. The supernovae explosion is powerful enough to blow a star into gas and dust. At the center of the Crab Nebula is a rapidly rotating pulsar. Gravitationally, the core of this giant star has shrunk to a tiny pulse model. This pulsatile has a diameter of only 20 kilometers, but it's extremely dense. A piece of material the size of a pinhead could weigh millions of tons. A gradual process of exploration. This pulsar will spin faster and faster. It's like a figure skater with arms outspread for a quick spin has folded them. Two beams of energy and radiation are rotating at a speed of 30 cycles per second. The radiation here is even stronger than the sun. If this pulsar comes as close to Earth as the sun, so the Earth's, it'll all be gone in an instant. This is the most destructive object we've encountered so far. A celestial body we didn't want to see came into view. It's pitch black. Even, the light of the star behind it was also, hide. We're looking at the remains of a giant star that exploded. It's a black hole. This star exploded and didn't explore into a white dwarf or pulsar. In contrast, it continues to explore, until it becomes a black hole just a few kilometers in diameter. Black holes are much denser than impulsive. It has an immense gravitational pull that no matter can resist. Once you get too close to a black hole, no celestial body seems to be able to escape its attraction. The gravitational pull of it is so great, not even the light. Run away. The asteroid was originally a hard rock, but now it's stretching under the gravitational pull of the black hole. We don't know anything about what goes on in a black hole. There's no time there. There is no room. Almost all the laws of physics don't apply to it. The asteroid is gone. De facto, no one knows where the asteroid went. Black holes test the limits of human scientific knowledge. Around the Milky Way, there could be millions of black holes lurking. More stars than we've ever seen in the night sky. Liberal Party, there's no way to find these black holes. This star may be circling an invisible black hole. Turn around. Is our universe in the middle of a giant black hole in another universe? That's something no one can warranties. Sometimes, it seems that the more we see, the less we know about the universe. But one thing is certain. The galaxy we live in is more complex than we thought. And more dangerous. Even though we've learned a few things about the Milky Way. But the vastness of the universe beyond our galaxy is still waiting to be explored. Just, ing, and nothing else, it's a wonder. Hazardous. There are many mysteries of the universe that have yet to be unraveled. But first, we must find a way out of the galaxy. It's 7,000 light-years from Earth. But we're still not out of the galaxy. To reach the edge of the universe, we still have millions of light-years to go. But there's a lot to see on this trip. For example, it is located in the English Qing Yun's creation of spine. It's a column of gas and dust. The pillar of creation is like a doorway to other distant cleanses. These two pillars are covered with tiny bumps. Stellar systems in their infancy. Each system is comparable in size to our solar system. It's another one of nature's masterpieces. But the spectacle won't last long. Because the pillars of creation are being eroded by radiation from a nearby star. Millions of years from now, the English nebula that created the spiders would have disappeared. And in the concept of astronomy, millions of years in the blink of an eye. Revel in the breathtaking beauty of the Milky Way. We've inadvertently entered a dangerous area. A giant gas cloud. It can come out of this star. This giant star is millions of times brighter than the sun. We're looking at a dying star. The nuclear reactions that energize it are winding down. The core of this star will explode. The eventual formation of a new astronomy black hole. Here's another one that's bigger. Stellar. It's extremely unstable. It's very dangerous. This star is about to explode. When a star of this size, in the event of an explosion, it will be more than 100 times more powerful than a supernova explosion. We witness the death of a supermassive star. It's the biggest giant supernova explosion in the universe. The core of the star will be released in an instant, and then a new black hole. A powerful shockwave shook the entire star, throwing the outer layers of matter out into the universe. Radiation from explosions is everywhere, enough to have catastrophic consequences for all nearby planets. About 450 million years ago, the Earth has experienced a mass extinction of species. This giant superplanet explosion may be the culprit. Beastly. Deadly giant planets, icy comets, scorching planets, and white dwarfs, red giants, Earth. All of these objects are just a tiny part of the vast Milky Way galaxy. We've been wondering. Except for the Earth. Where else in the universe could there be a place for humans to live? Solution. Maybe it's right here. On Earth. From tiny insects to tall mountains. And even vanished or existing human civilizations. Including every life that has ever come into this world. From the vastness of the universe compared, all this is just a drop in the ocean. Where we live. The sphere is just a tiny star in a tiny star system. Planets. In the event that the Earth is now suddenly gone, it won't have the slightest effect on the entire universe. Lit. The time up today, idiom, up to the present, we still haven't found a planet more habitable than Earth. Tokyo Township, capital of Japan, TW, we haven't even been able to find a place where humans can survive. At that point, the universe is dotted with countless stars. There must be a star or stars among them that are capable of harboring life. This is the M13 globular cluster. We might be able to find the star we're looking for here. 1970s, astronomers send a set of messages to the M13 globular cluster. Detailed description of the structure of human genes and the composition of the solar system. However, due to the distance of the M13 globular cluster from Earth is too far away. It will be at least 25,000 years before this set of information can be getting there. At the present time, we haven't found any alien life yet. But there's no reason to deny the existence of extraterrestrial life. They're probably out there somewhere in the universe. Scientists have invented a formula. This formula can estimate the number of other advanced civilizations in the universe. The estimates are quite impressive. There could be millions of civilizations within the Milky Way alone. Hitherto, everything we see is located within the Milky Way. Present. We're going on a new journey. Travel to other galaxies to explore more distant universes. Where on Earth did everything in the universe come from? We may be able to find the answer to this question. We're about to leave. Leave the solar system. Leave our galaxy. We're beyond the Milky Way. Into the vast space of star wonders. It's here. Even the closest galaxies are hundreds of thousands of light-years away. The Milky Way's immense gravity has torn apart some galaxies. Their remains are scattered in the silence of clear-level space. Clear-level space is the closest thing to a complete vacuum in the universe. But even here, it's not a complete vacuum either. There's still some thin gas and fine dust here. In addition, this, and dark matter. Dark matter is so mysterious. We can neither see its shape, I can't feel it either. It's even more impossible to measure its size. Nevertheless, and dark matter is so common. It and dark energy represent over 90% of the matter content of the universe. If dark matter does exist, this means that there is no such thing as an empty place in the universe. Abbreviation for square or cubic meter. Even in galactic scale space, we're also surrounded by a lot of matter. But we can only speculate on the existence of dark matter, because it has a major impact on galaxies, like the Big Magellanic Wheel in front of us. Muscovitum. The Wheel of Wheat Cloud is more than 160,000 light-years from the Milky Way. Even if we go there in the fastest spacecraft available, It would also take more than 6 billion years of flight to enter the galaxy's gravitational field. The Great Magellanic Cloud is supposed to be out of the Milky Way on its own. Now it's a satellite galaxy orbiting the Milky Way. This may be due to the invisible and powerful dark matter. Planets, clusters, nebulae. It's like a giant celestial treasure trove. This bright, my halo is the product of a supernova explosion. This supernova is very bright. In 1987, people could see the light from the explosion with just their eyes. This violent supernova explosion triggered a series of nuclear reactions. Causes atoms to crush each other. This has led to the creation of many new elements, including gene membranes. These new elements were thrown out into the universe in the explosion. Nowadays, we wear the gold used in the ring. It was created in a similar supernova explosion. Such an explosion could have happened billions of years ago. Trillions of kilometers from Earth. It's a surprising discovery. Those stars look so far away from Earth. But it has a direct impact on our lives. We continue in the universe, move forward, come to a delightful place. This is the Andromeda Galaxy. About 2.5 million light-years from Earth. It's traveling through the universe at nearly 1 million kilometers per hour. All the objects in the universe are moving away from each other. It's like the debris that flies when a bomb explodes. The Andromeda star device we see now is what it looked like 2.5 million years ago. Our human ancestors had just appeared on the plains of Africa. As we move further forward, we're getting a glimpse of what it was like much earlier. It's a galaxy that's exploding. There's only one thing that could have triggered an explosion of this magnitude. That's a collision with another galaxy. This galaxy won't just fade away. It will be reborn. It will take on new shapes, even spawning new stars. The mutual collision of gas and dust generates huge friction and shock waves. This allows new stars to form. The universe with its countless celestial bodies may seem chaotic. But it also has its own unchanging pattern. That's the cycle of celestial bodies between birth and death, creation and destruction. This law ties all galaxies together. There are billions of galaxies in the universe. Each galaxy has billions, if not trillions, of stars. Consequently, stellar, there are probably more grains of sand than on all the beaches on Earth. And we're only counting existing stars. Not taking into account the stars that have died out, are forming, and will be born in the future. We finally have a more complete understanding of the universe. It's bigger than we could have ever imagined. This giant Will galaxy is very far from Earth. It takes 27 million years for a message from Earth to reach here. Until this moment, the planet we live on may be long gone. Let's continue this journey through time and space. Walked 6,500. The moment the dinosaurs went extinct more than 10 million years ago. Walk through the moment when sea creatures crawled onto land more than 300 million years ago. We've come 2 billion light-years from Earth. We're approaching the edge of the universe. Back to the origins of time. It's not a galaxy, but it shines brighter than hundreds of galaxies combined. The dazzling light spreads to tens of thousands of meters, kilometers away. It's so huge, so bright, unleashes incredible energy. Experience tells us that, in the universe, the more energy an object has, the more dangerous it is. It's a quasar. It's the most energetic object in the universe. Taxoid, it's made up of very hot gases. Its brightness exceeds the sum of hundreds of hydrogen. The great energy of a crystal-like object comes from its core. The core of the quasimorph is a supermassive black hole. Its mass is equivalent to 1 billion solar. This black hole is capable of tearing apart an entire star and draws the star's gas into the quasar. It's devouring the star until the star ceases to exist, lost forever in the universe. We've met the most powerful and destructive object in the universe. Now we're getting closer to our destination. The edge of the universe seems to be just reach. But to reach the true edge of the universe, we have to go further. Be able to walk faster. It's 8 billion light-years from Earth. We're seeing more galaxies. But these galaxies are different from what we've seen before. They come in all shapes and sizes. Smaller, and they're very close to each other. The galaxies we see now are what they looked like before the Earth was formed. These galaxies are still very young. It's growing. Where does everything in the universe really come from? We're getting closer and closer to the answer to that question. This is what the universe looked like 121 years ago. These galaxies are like floating in a vast expanse of water. Primitive plankton in them. It's such a fascinating sight. Huge clouds of gas and dust flutter across the universe, slowly forming countless galaxies in their infancy. This is what our galaxy looked like when it was first born. Through these galaxies, we've come to a universe before stars were born. We saw the birth of light. It's the product of a Big Bang. It was the Big Bang that made the universe what it is today. Our destination is right in front of us. We're finally here. We did it. This is the universe. Margins. It's 1,300 trillion kilometers from Earth in space. 13.5 billion years ago in time. This is the moment when the Big Bang happened. It was also the most turbulent and creative moment in the history of the universe. Everything in the universe, it all starts at this moment. Every religion, every culture, all have explored the question of the origin of the universe. But we still haven't completely solved the mystery. Here are. It's the end of our journey. And the beginning of Zeus. A point of very high temperature, very small size and very high density exploded. The explosion produced space, time, matter, and the universe itself. At the outset, it's smaller than an atom. But in the blink of an eye, it swells to the size of the palm of your hand. Just a moment. It's the size of the Earth. Nowadays, light from the Big Bang is still traveling. This light manifests itself in their interference with the radio. When the TV antenna in your home is not receiving a signal, we'll be able to see it on TV. Present. We're about to sail home. Everything we see on our journey is a product of the Big Bang. Weekly stars, stars. These objects are just debris from the Big Bang. Let's go back to the Milky Way. Back to our solar system. We're back where we started. Back on Earth. The Earth is also a piece of debris from an explosion. It's spinning in the afterglow of the Big Bang. But the story of the universe doesn't end here. The effects of the Big Bang continue. The whole universe is still in flux. More than 30 years later, giant Andromeda galaxy to crash into Milky Way. A new planet will be born. The sun and planets will still be around. But they're going to be thrown into a giant orbit. Orbiting a new planet. The sun will become a red giant star. After devouring Mercury and Venus, the sun will scorch the Earth. It means that all life on Earth will end. Since then, the sun will collapse into a white dwarf. Until it dies out. The stars near the sun will also disappear. In its place will be a pulse of white dwarfs. And black holes. This week's brightness will diminish as well. Since the Big Bang, the entire universe is constantly playing out the decline and demise of celestial bodies. It's a long and painful process. But maybe we can find a way to escape. This is being, the dying universe. Through tireless efforts, our children and grandchildren may find a shortcut through time and space. That's the wormhole. If there are other universes out there, then Oki might be able to take our children and grandchildren to another poor universe. Just, ing, and nothing else, our children and grandchildren may be able to find one in the prime of life. The Earth. If our children and grandchildren are lucky enough, they may be able to find a new home in another universe.